Welcome. This is Algebra 1, Chapter 2 now, and I'm going to be just doing an introduction to inequalities, and especially how inequalities would look on a number line. So, you guys know that inequalities are probably something that have signs like this, or this, or this, or this. Now, what do these signs actually mean? How would I read them out, and how would they look on a number line? That's what I'm going to talk about today. So, let's take this inequality, x plus 4 is greater than 8. So for what values would x plus 4 is greater than 8 be true? So let's say x is 1. 1 plus 4 is greater than 8, right? No. 1 plus 4 is actually 5, and 5 isn't greater than 8. So I'm going to have to try a different value for x. There's actually a faster way to solve this, but I just want you to understand when inequalities are true and when they're not. So let's take the value. Let's take x is equal to 4. 4 plus 4 is 8, but is 8 really greater than 8? No, it's not. 8 is equal to 8. 8 could be greater than or equal to 8, but it's not greater than 8. So x cannot be 4. But I think x can be anything greater than 4, right? So 5 should work. 5 plus 4 is 9. 9 is obviously greater than 8. X could be 10. 14 is greater than 8. Yeah, that's true. So that's how you'd say an inequality is true. I just wanted to look at that before I got into number lines and stuff. So let's get into number lines. I'm going to draw my number line, and I'll put arrowheads at the end to represent that it infinitely extends. And I will mark 0. I'm not going to mark exactly the dimensions or like the increments this number line goes by because I'm not sure what inequality I'm going to do yet. So say I have the inequality x is greater than or equal to 6. To graph this, I'm going to make it convenient for me, and I'm going to do this by, let's say, 3s. So 6, 9, 12, 15, and then on this side be -3, -6, and so on. I don't really care about this side because x is actually greater than or equal to 6. Nothing below 6 is greater than or equal to 6. So notice how the sign has a greater than or equal to. So what does that mean? How would I show that? Actually, there is a way to show that, and if it's greater than or equal to, you'd fill in your little circle and make it completely dark. But then if it was just greater than, it'd just be an empty circle. So you just kind of have to remember this. I don't know any tricks, and it's actually really simple to remember, so yeah. And so I'm going to mark this side with a closed dot. It's not really a dot, but best I can do. And I'm going to extend it greater than 6, so to the right, and I'm just going to darken this side of the number line to show that any value of x is greater than or equal to, so I'm marking that with the closed dot, and I'm just making sort of like a ray on the other side. And so this shows that all of these values all the way down is x. Now let's look at a case where I have an x, or let's take a different variable for fun. M is less than -2. This is the exact same concept. I would just take this, draw my number line, and for convenience, I'm going to put 0, 0, like maybe farther over here, and then -2 over here, and this graph is going to increase in increments of 2. So it'd be -4, -6, -8, so on and so on. So I would put my open dot at -2, and I just darken this part of the graph. Let me do it in a different color so you can see it better. Just darken it, put an arrowhead to show that it's an infinite thing. And that is my inequality graphed on a number line. There is more complex parts of inequalities, but that's on coordinate planes, and that's too complicated to get into. So for now, just know that you can graph these sort of inequalities on the number line, and you can find where all the values of m are at. So all of this, all the way down, would be values of m. Any value over here, anything, like negative 6.42, that is a value of m, because that's less than negative 2. So yeah, that's all you need to know for today. I will be uploading frequently. So thank you. Bye-bye.